file management systems. The discussion topics are: define management systems, describe the components and functions of a file management system, compare the logical and physical organization of files and directives, explain how secondary storage locations are allocated to files, and describe the data structures used to record these allocations. Continued discussion topics: describe file manipulation operations, list access controls that can be applied to files, describe file migration, backup, and recovery methods, explain methods for ensuring fault tolerance, compare storage consolidation methods such as storage area networks and network attached storage. Definition of a file management system is: a file management system is a type of software that manages data files in a computer system. It has limited capabilities and is designed to manage individual or group files. An FMS is implemented in the following layers, which are similar to those in an operating system: command layer and application program. The command layer is the user interface to the operating system. Through this layer, a user or system admin can run application or OS utility programs and manage system resources such as files, folders, I/O devices, secondary storage. Then we have the file control layer. The file control layer is a bridge between logical and physical views of secondary storage. The storage I/O control layer. The I/O control layer is a part of the kernel that accesses storage locations and manages data movement between storage devices and memory. Software modules in this layer include the following: device drivers for each storage device or device controller, interrupt handlers, buffers, and cache managers. And finally, the storage device layer. There is a logical and physical storage view. Users view secondary storage logically as a collection of files organized in directories and storage volumes. Physical storage is the volume also known as the physical disk, removable storage such as DVD, flash drive through a linear address. Here's an example of system layers: an operating system and in a FMS. On the left side is the operating system layers, and on the right side you can see is the file management system layers. Now we're going to look at the logical view versus a physical view. A file is subdivided into records. A record usually contains information about a single customer or employee, a thing such as a product, an inventory, or an event. Records are broken down into fields. Fields, or data fields, are individual units of data. Here's an example of logical view and physical view. On the logical structure, here's an example. If you look at the top, there's the fields and records. The logical file structure is independent of the physical device on which it's stored. A number of physical structure characteristics, such as the following, are simplified or ignored in the corresponding logical file structure: physical storage allocation, data access methods, and data encoding methods. Next, we're looking at physical storage. Physical storage allocation considerations include placement of fields and records in a file and distribution of a file across storage locations, media, or devices. Access factors include whether file content is accessed sequentially within an index or by some other method. Data encoding issues include the data structures and coding methods for representing each field. Related issues include data encryption and data compression. File types. A file can store many different data types, including text, numbers, complex data structures, and executable instructions. An FMS normally only support a few file types directly, including the following: executable programs, OS commands, text or unformatted binary data. Among other things, file type determines the following: physical organization of data items and data structures in secondary storage, operations that can or can't be performed on the file, file name restrictions. File type normally is declared when a file is created. In the Unix file management system, the file type is stored within the directory. In the Windows file management system, the file type is declared through the extension. The relationship between file types and the programs or OS utilities that manipulate them is called file association. Directory content and structure. A directory contains information about files and other directories. Some directories are created and maintained by software. Windows directories, directories associated with applications. At the bottom is an example of a Windows directory. User can also create and maintain directories. Directory content and structure. A directory contains information about files and other directories. All files and directories must have a unique name. The following are typical rights of the file owner: list, read, modify, and change. FMSs store one or more times stamps which can include those listed below: when the file was created, when the file most recently was read, when the file most recently was written, and when the file last was backed up. Hierarchical directory structure. Hierarchical directory structure is how an OS's file system and its files are displayed to the user. Windows directory structure is a hierarchical. Directories can contain other directories called subdirectories. Directories cannot have more than one parent, sometimes called a tree structure. Hierarchical directory structures. For each process or user, the OS maintains a pointer to the directory that's currently being accessed. This directory is called the current directory or working directory. Storage allocation. User and applications programs continually create and change files. When files are created, they must be given space and storage. When files grow, they must be given additional space. When files shrink, unneeded space must be released. Allocation units. The storage I/O control layer allocates secondary storage locations to files and directories. An allocation unit is the smallest number of secondary storage bytes that can be allocated to a file. Data transfer unit is called a block. Block sizes range from 512 bytes to 4 kilobytes and multiples of 512 bytes. Allocation unit size is a trade-off among the following factors: efficient use of secondary storage space for files, size of storage allocations, data structures, efficiency of storage allocation procedures, sample allocations of files. The next 3 slides show 3 files, how their storage is allocated, and how FMS records location of allocation units. Storage units are said to be chained together using pointer. Each unit contains reference to the next unit in the list. Graph directory structures. A graph directory structure is more flexible than the hierarchical directory structure because it relaxes 2 of the restrictions enforced in a hierarchical directory structure. Files and subdirectories can be contained in multiple directories. Directory links can form a cycle. Pointers from one directory to another are called links in Unix and shortcuts in Windows. Blocking and buffering. Some application programs access files by logical records. A logical record is a collection of data items or fields that is accessed by an application program as a single unit. A physical record is the unit of storage transferred between the device controller and memory in a single operation. For disk and other devices used fixed size data transfer units, a physical record is equivalent to a block. For storage devices with variable size data transfer units such as tape drives, block size might differ from physical record size or be undefined. If the logical record is less than the physical record size, a single physical record might contain multiple logical records. If the logical record size is larger than the physical record size, multiple physical records are needed to hold a single logical record. Blocking. Logical record grouping in a physical records is called blocking. Blocking factor is described by a numeric ratio of logical records to physical records. If a physical record contains just one logical record, the file is said to be unblocked. If you look below, these are descriptions of blocking. Buffer. The FMS uses buffers and primary storage to store data temporarily as it moves between programs and secondary storage devices. Buffers are allocated automatically when the file is first accessed and managed by the OS. on behalf of application programs. Each buffer is the size of one allocation unit. The FMS extracts logical records from the buffers and copies them to the data area of the application program. The procedure is reversed for write operations. The buffer is a temporary holding area for extracting logical records from physical records. Here's an example of the flow using buffers. Next is file manipulation. File management systems provide service functions in the file control layer to enable application programs to create, copy, move, delete, read, and write files. Application programs interact directly with the FMS through the operating system service layer. Users interact with the FMS indirectly through the command layer. File open operation. The FMS must perform several tasks collectively called a file open operation. In response to the service call, the FMS performs the following steps. Locate the file in the directory structure and read its directory entry. Search an internal table of open files to see whether the file is already open. Ensure that the process has enough privileges to access the file. Allocate one or more buffers. Update an internal table of open files. FMS maintains an open file table to prevent application programs from interfering with each other's file and output activities. File close operation. When an application program finishes reading or writing a file, it executes a file close service call. The FMS completes the file close operation by performing these steps. Flush the program's I/O buffers to secondary storage. Deallocate buffer memory. Update the file's directory entry timestamp. Update the open file table. Delete and undelete operations. In most file management systems, files are not removed immediately from secondary storage when they are deleted. The file storage allocation units are marked as free and its directory entry is marked as unused. As new files are created or existing files are expanded, the deleted files allocation units are reassigned to other files and overwritten with new content. Handling file deletion in this way is efficient, but it has two important consequences. Files can be undeleted by reconstructing directory and storage allocation table contents. File content can be visible to intruders who can bypass the storage allocation table and read allocation units directly. Access controls. An FMS helps prevent loss, corruption, and unauthorized access to files. The operating system identifies and authenticates users and their processes. The operating system that enforces access control, each user has a unique account name or ID number and must authenticate their identity. Enforcing access controls reduces the speed of many file access operations because of the extra processing required. Different FMSs have different access controls. Unix defines 3 access control types: read, write, execute, backup operation. Most FMSs include general-purpose utilities to create backup copies of files and directories on removable or remote storage media. Backups protect against lost data caused by storage device or media failure. Backup copies can be transmitted to remote storage facilities via high-speed network, eliminating the cost, delay, risk of physical transporting storage media. Types of periodic backups include the following: full backup, incremental backup, and differential backup. Full backup is when the FMS copies all files and directories for an entire storage volume. An incremental backup only archives files that have been modified since the previous incremental or full backup. A differential backup is a variation on an incremental backup in which backup times aren't reset as files are copied. Recovery operations. Recovery procedures have both automated and manual components. Transaction log, reply, and subsequent file repair is usually fully automated. Recovery procedures based on full or incremental backups stored on a removable media usually rely on manual procedures to some degree. Recovery procedures for a crash system or physically damaged storage device are usually more sophisticated and highly automated. The recovery utility reconstructs as much of the directory and storage allocation data structures as possible and makes a consistency check to ensure the following: all storage locations appear in the storage allocation table and other data structures. All files have correct directory entries. All storage locations of a file can be accessed through the storage allocation table. All storage locations can be read and or written. Storage consolidation operations. Direct attached storage, DAS, describes any architecture in which software running on a CPU accesses secondary storage devices in the same computer. DAS can be expensive and inefficient for organizations with dozens or hundreds of servers due to storage overlap between servers. Two approaches are widely used to overcome the inefficiencies of DAS in multiple server environments: Storage Area Network, SAN, Network Attached Storage, and NAS. Below is a diagram of both. In summary, the File Management System, FMS, usually a part of the operating system, manages all aspects of user and program access to secondary storage. The FMS system is implemented through the various system layers: command layer, file control, system I/O control, and storage device layer. Within the various layers, data is either represented as logical or physical organization of files, directories, data, and stored in secondary storage. To ensure the easy management of files and directories, integrity, security of stored data, the FMS provides easy file management GUIs controlled to secure information and the ability to back up information to reduce the likelihood of losing information. Thank everyone for your time, and I hope you enjoyed the presentation.